Translating natural language into verified, executable plans has always been a bottleneck. LLMs hallucinate PDDL, and classical planners demand formal syntax. Recent agentic frameworks bridge this gap by routing repair tasks through a pool of specialized agents, but they hit a hard wall. Every refinement step requires a costly, API-dependent frontier LLM as the orchestrator. What if we could train the orchestrator itself? Enter Halo, a hybrid agent-learned orchestrator that replaces that per-step API call with a small, locally served model. The key insight is that the training signal is already baked into the framework. Because every refinement loop is guarded by formal tools like fast downward and VAL, any trajectory that reaches a valid plan is a sequence of demonstrably correct state-to-agent decisions. Halo treats those verifier-certified trajectories as supervised demonstrations, using the validator strictly as a data acceptance filter rather than a loss signal. We expanded the agent pool to 21 actions, mixing standard LLM-prompted repair routines with 5 deterministic plan repair algorithms and 3 PDDL-aware modeling agents. Crucially, we don't train the model on every decision. 3 choices, cold start recovery, syntax error handling, and plan termination, are trivially rule-decidable. Halo routes those through hard-coded logic, reserving the learned policy for genuinely ambiguous orchestration steps. The model itself is fine-tuned via QLoRa with single-token cross-entropy, predicting exactly which agent ID to invoke next without wasting capacity on patterns a rule already resolves. The results are stark. Across 11 PDDL domains, Halo matches or exceeds GPT-5 Mini on success rate, sits within 3 percentage points of Gemini 3 Flash, and slashes orchestration costs by more than 45 times, dropping from 18 cents to 4 cents per task. Total LLM calls per episode drop by nearly half. Inference runs on a single consumer GPU in under 10 milliseconds per decision, completely removing the dependency on frontier model APIs. This proves that when an agentic framework is anchored by a formal verifier, the orchestrator doesn't need to be a massive, cloud-hosted model. It can be small, trainable, and local. By distilling verifier-accepted trajectories into a hybrid policy, we're not just cutting costs, we're making rigorous, end-to-end automated planning viable for edge devices, air-gapped labs, and production systems that can't rely on continuous API access. The future of agentic planning isn't just bigger prompts. It's learned, verified, and local.